Hey Garrett,
Hello.
how are you?
Good.
Good. Um, do you have specific ones you have questions on, or you just want to work through the whole worksheet?
I want to go through the whole worksheet, and I'm kind of rusty on this stuff, and I don't remember much of it. So forgive me if I sound kind of stupid because I have
Oh,
pretty much no idea what I'm doing.
hey, let me tell you, when it comes to trigonometry, I have to freshen my skills almost every year. It the only blessing is that each year the freshening gets a little shorter. But it's I know there are lots of people that rock at this stuff, but you- I really have to go slowly through it because for me, there's so many little intricate details that there's lots of places to make simple mistakes. You know what I mean?
Hmm.
So we'll get started. Sorry, I'm looking for my stylus. Um, okay, so finding each measure and round all answers to the nearest tenth. And just kind of a word of caution to you on that nearest tenth, most people do use the nearest tenth, but I have seen places where it'll say the nearest hundredth, like, ACT, SAT. So always be real careful of that. But obviously, those places, it's multiple guess, but you want to make sure when you're rounding that if there's multiple steps, that you're rounding the same way each time to get the most exact answer. Does that make sense?
Yeah.
Okay. All right. So what you want to look at is you are given the angle 26. And so then you want to look at the sides that they have given you and figure out how they relate to that angle 26. So in these, obviously these are always the legs. Well, if Miss Sparks could trace the legs are always the ones that surround the right angle. So as X relates to the angle 26 in the way that it's adjacent to that angle. So you've got an adjacent over hypotenuse. And this will help you figure out which trig ratio that you're supposed to use. And that is, if I'll just write SOHCAHTOA over here. So adjacent over hypotenuse is cosine. Okay. So you've got cosine 26 equals x over 15. So you just multiply both sides by 15 to solve for x. And that the rest, if Miss Sparks could write, the rest is just calculator work. So you just literally type in 15 times and then hit cosine. It opens a parenthesis. You put in 26 and then you get an answer. 13 point something. Yeah.
Yeah.
And if you round, that should be 13.5. I think it was, what was it? 13 point, what'd you tell me? 48? What is
Yeah.
it? Okay.
Right.
Okay. So on number 2, you look at your angle 49, and then you see how the sides correspond to that angle. Well, you've got an opposite side, so opposite, and then you're also given the hypotenuse. So what trig ratio is opposite over hypotenuse?
Um, I forgot which one. I don't have it with me.
It's right, SOHCAHTOA. I wrote it at the top so you could refer to it. And so the sine is opposite over hypotenuse. That's why it's SOH. Sine opposite over hypotenuse. Ka is cosine adjacent over hypotenuse, and TOA tangent opposite over adjacent. So opposite over hypotenuse is
Would it be
sine.
sine? Oh, yeah, okay.
Yeah.
Now I understand how that works. Thank you.
Okay. Yeah. Sine 49 equals, and then you just plug in what you know, x over 24. So then to solve for x, you multiply both sides by 24, and then the rest is just calculator work. So you just plug in your calculator, 24 times sine 49, enter.
18.1.
Yep, that's it. All right, on number 3, we've got the opposite side, because these are always the legs that surround the right angle are going to be always your opposite and adjacent angles, or your adjacent sides. Okay. And in this particular one, we have opposite over adjacent. So that's going to be our tangent. So tan 14 equals 18 over x. And I don't know if Miss Wynn proved this in class yesterday.
You need to divide when it's the other way around, right?
Yes. All you have to do is really swap the position of the tan 14 and the x. That's the shortcut. You can prove that algebraically, and I did it in my class yesterday, but legitimately you can use the shortcut 18 over tan 14. So once again, once you get to that point, just calculator work. You'll just plug in 18 divided by tan 14 and hit enter.
That always gave me a hard time back in geometry.
I'm sorry?
That gave me a really hard time back when I took geometry.
Oh, it did?
Yeah.
Like being able to swap right there? Like when the X is on the bottom?
Figure out when I need to do it and how to do it correctly.
Ah, I got you. If X is on the bottom, you can swap it. If X is on the top, then you're just multiplying by the denominator.
Okay. I guess that's easy enough to remember.
And here's the proof of it, really. Here's the long way of doing it. If I have tan 14 equals 18 over x, whenever you have a fraction in algebra, in order to get rid of the fraction, you multiply both sides by the denominator. So if I multiply x over here and x over here, then I get x tan 14 equals 18. Well, to get x by itself, when it's attached to something, you have to divide by whatever's attached to it. So even if you worked it completely out algebraically, you'd still be okay. But it's nice to know that there's a shortcut. You know what I'm saying? But there's the algebraic proof of why that works. I don't know if that will help it stick for you, but like up here on number 2, when x was in the numerator, we were multiplying both sides by 24 to get rid of the 24. And that's how the 24 ended up over there. So that's how that works and why it works. You're still, no matter how you look at it, you're still multiplying by the denominator. It's an unknown denominator. So it's one additional step. So praise God for shortcuts, as long as you can remember what and why when x is in the denominator. Okay, number 5. You're looking at the angle 67 and how the sides relate to it. So you've got an adjacent side and then the hypotenuse. Because this 5 is adjacent to the angle that you're looking for. It's the adjacent leg. And then the x is the hypotenuse. So adjacent and hypotenuse is which trig ratio?
Cosine.
Good job. So cosine 67 equals your adjacent side length is 5 and the hypotenuse is unknown. So once again, our x is in the denominator. So that's when we can use the shortcut. So x equals 5 over cosine 67. So that's just calculator work.
Is it 12.8?
Yes, it is. Good job. All right. Number 5. We don't have enough information right off the bat to get x. So what we need to do is look for the length of the side that the triangles share. So I'm just going to give it the label y. And because I know you're thinking in your head, why do I have to do that? So it just fits the situation. Anyway, so now we have a side length that's shared by both of the triangles. So if I can find that, then I will be able to come up with a trig ratio that will give me that will allow me to solve for x. So now I will use the information that I have on the larger triangle to get that angle. So I'm going to work with this angle 53 that's given. And I've got an opposite leg over the hypotenuse. Because this leg is, this is opposite of the angle, and it's one of the legs that hugs the right angle. So I've got opposite over hypotenuse. Now, which trig ratio is that?
Sine.
Sine. So sine 53 equals 30. No. Y over 30. So I'm going to multiply both sides by 30. And that equals what?
24.
24. Good job. It's like 23.9 something. So it's close enough to, and it's a heavy 9. So it's, you can round that to 24. All right. So now I have the length of this side, and I can use a trig ratio to figure out this other one. So I've got the adjacent angle, or the adjacent side in this smaller triangle, and I've got the hypotenuse. So which trig ratio is that one?
Cosine.
Cosine. Whoops. Cosine 75 equals x over 24. Multiply both sides by 24. And what do you get?
6.2.
That's right. All right. Now, these are where you start with the inverses of sine and cosine. So we're looking for the angle measure. So we're given x as the angle, and we have opposite over hypotenuse. So what trig ratio is that one?
Sine.
Sine x equals 32 over 35. So x is going to be sine inverse 32 over 35. So you'll hit second on your calculator. You hit that second button and then sine. So that should give you a little sign with a -1, right? And then type in 32 divided by 35. Close your parentheses and hit enter.
66.1.
That's it. So that angle measure is 66.1. So on this one, we have 2 leg measurements given, and we have opposite over adjacent. So which trig ratio will that be?
Tan.
Yep. Tan x equals 15 over 13. So x degrees is tan inverse 15 over 13.
Is it 49?
49.1. Good job. Good job. Degrees. I haven't put my little degree symbol there. Make sure you put your degree symbol. All right. On number 8, we have the adjacent side with the hypotenuse. So which trig ratio is that?
Kind of close call for me. Is that opposite over hypotenuse?
Oh, I'm sorry. That's adjacent over hypotenuse.
So that'd be cosine?
Yes. Good job. Cosine of I'm gonna rewrite it here. Cosine x equals 26.2 over 27. So x equals inverse cosine 26.2 over 27. So what is that?
No, that'd be 14.
14 degrees. Good job. Okay, on this one, we're dealing with opposite over hypotenuse. Opposite, and then this is the hypotenuse. So sine. Good job. So sine x equals 10 over 19. So x equals inverse sine 10 over 19.
31.8.
Good job. All right. David is standing, and please, I'm not a very good drawer. So I'm just going to probably mostly make triangles or boxes. All right. David is standing 500 feet away from the base of a cell phone tower. The angle of elevation, which I try to underline what they're looking for, from his eyes to the top of the tower is 78 degrees. Because on these, you're either looking for an angle of elevation or angle of depression, or you're given an angle of elevation or an angle of depression and working from there. If David's eyes are 6 feet above ground, how tall is the tower? So I have this 500 feet, and I have my little stick man, who's David, and those are his eyes, and they're 6 feet above, but it's not really that important on this, but I drew him anyway. And that really is supposed to be a triangle with a straight line. But the angle of elevation is 78 degrees, and this is 500 feet. And what they want to know is how tall the tower is. So I've got opposite over adjacent. So what trig ratio is that?
10.
10. 78 degrees with x over 500. And so that's going to be 500 times tan 78 equals x. So just plug that into your calculator.
Is it 2,352.3?
I got 2,358.3. Did you type in tan 75 by chance, maybe?
I typed in 500 times tan 78.
Huh. Let me retype. Oh. Yes, I did get that. And now I know why it is important about his height. I wondered what that is.
You had to factor in 6 feet?
Yes! I just had a light bulb moment right here. I just went along with whatever my answer was before. There you go. And then this is his eyeballs are 6 feet. So you add 6, and then you get 2,358.3. So there's where the 6 feet comes in.
Okay, that makes sense.
Okay. We got it. I guess I just left it. I guess I just left it there. And then when I looked at the answer key, I was like, oh. Okay, the angle of elevation from the top, angle of elevation, so I know what I'm dealing with, the top of one building to another is 26 degrees. So we've got a shorter building, and then there's a taller building. The shorter building is 400 feet. And then we've got a taller building. Nice buildings, aren't they good? Oh, you can draw. So you're probably like, oh, Miss Sparks, you poor thing. Okay, in the buildings, I forgot what an amazing drawer you are till this moment. So I'm really embarrassed. Don't judge me, Garrett. Okay, so the buildings are 1,500 feet apart. All right, so now it wants to know how tall the other building is. Okay, so then there's the angle of elevation from here to there right here. That's 26. That is supposed to be a 26 right there. So what it's going to do is now we can figure out what this piece is. So whatever that piece right there is, we can add the 400 to. So we've got, and then we've got this leg right here, which is 1,500 feet. So we've got opposite over adjacent this time. So we've got opposite over adjacent because we've got x over 15. So what trig ratio is that?
Tan.
Yes, tan 26 degrees equals x over 1,500. So 1,500 times tan 26 equals x.
$731.6.
731.6. Yeah, that's what I got too. So now we need to add, I won't mess this up this time, the 400 back in to find the total height of the building. And that would be 1131.6 feet is how tall this building is. Does that make sense?
Mm-hmm.
Could you do them on your own now?
I mean, maybe, but I'd probably make a mistake.
All right. Well, let's talk this one out. Okay, there's a 200 foot supporting cable tied to the top of a cell phone tower, then secured to a point on the ground. So basically what that's telling us is that it starts at the top of a tower and is tied to the base of the ground. If the angle of elevation from the point on the ground to the top of the tower, so that means this angle is 38. Well, 38. It wants to know, this is 200. It wants to know what the height is. So we're given opposite over hypotenuse. So what trig ratio is that?
Sine.
Good job. Sine 38 equals opposite, which we don't know, x over 200. Multiply both sides by 200. Would you be able to draw these? I mean, obviously you would be capable of it because you're an artist, but would you be able to reason them out from the words, I guess is what I'm saying.
I'm really bad with visualizing things like that.
Okay.
But I probably could figure it out if I looked at it hard enough.
Okay. Well, we're going to move to, I should have done a better job of asking questions. Please forgive me. But the next one is angle of depression. And these are a little different because to me, the ones with the angle of elevation are a little more straightforward. The angle of depression are the ones where you can either do the complementary angle or use the angle of depression and use the fact that you can make like a parallel rectangle with it. So the angle of depression from the top to the bottom of a ski lift is 43 degrees. So the angle of depression when you're doing these is going to be, oh my, that's really bad. The angle of depression is this angle right here. So it says the vertical distance between the top and bottom of the lift is 800 feet. So I know it's 800 feet from top to bottom here. So I know it's going to be 800 feet over here. That's that whole parallel line thing. Because you can't, like if I was drawing them like I was before, it's not this angle here. Let me do that. It's not this angle here that's the angle of depression. It's this one over here. And the angle given is 43. Now, if you were drawing it like we were before, then you would take that complementary angle, which would be 90 minus 43, which that's 47. If you were going to use the trig ratios to find out this one. But the angle of depression is the one from the top to the hypotenuse that's formed. Does that make sense?
Not really.
You're okay. Determine the length. This is the cable. If I was better at drawing this, this is the cable that goes from the top of the ski lift to the ground. And we know that the height of the ski lift is 800 feet. Okay. So this forms a right angle. Let me just draw that. Okay. With the information given, I would draw this right here. I've got an 800-foot tower, ski lift tower. And I know that there's a cable that extends from the top to the ground. The angle of elevation or the angle of depression is this distance. The distance between the horizontal line at the top of this triangle, this basically is parallel to the ground. But the angle of depression is from like this line here that is parallel to the ground line. Does that make sense now? Because I made that dotted line. It's almost like this imaginary line, which I didn't really do it imaginary over here. So let me do that. The information that we're given in the problem gives us the angle of depression, which is the distance between the cable and what would form a right triangle up at the top.
Okay, that makes sense.
Okay. Oh, praise God. So this is this is kind of this other secondary imaginary triangle, if you will. So one way that we did it in class yesterday, if y'all did, as one of the, when we started on the angle of depression problems on the back half of the notes page, what we did the first time is found this angle, and then we did the trig ratios based on it. And then found the other one. But instead of doing that this time, we just kind of shortcutted. And I went ahead and drew the additional pieces of the imaginary triangle or rectangle, really, so that we could see that secondary triangle. Does that make sense?
Mm-hmm.
Because that way I don't have to do I don't have to do any subtraction, et cetera, et cetera, et cetera. What we're looking for is the length of this cable. So I'm going to use this angle. If I would have used actually, you could use the 47, but you would be using like a different trig ratio. Do you see that? Like if I took the 90 minus 43 equals 47, I would be using adjacent over hypotenuse. But in this case, I'm going to be using opposite over hypotenuse. Does that make sense?
Yeah.
Okay. So if I use opposite over hypotenuse, which trig ratio is that?
Sine.
Sine. Good job. 43 equals 800 over x. And the other one, I would have used cosine. But you have to make sure you do this step. That's the difference. If I go ahead and draw my imaginary second triangle, then I can go straight into my trig ratio. If I use the other one, I have to do this first. Because the angle of depression is where you start from that imaginary horizontal to the bottom. And what did you get?
1,173.
Yeah, that is correct. Okay. An airplane is descending to a runway at an altitude of 15.2 miles. Its horizontal distance to the runway is 60 miles. Find the angle of descent. Okay, so it's 15.2 miles in the air. The horizontal distance between the runway and the plane is 60 miles. We're finding the angle of descent, which is the angle of depression. So it's this angle right here. Okay? So we want to use that piece of our imaginary triangle that we've drawn. So what we know by our good old geometry postulates and theorems is that this side is equal to the other side. Because that hypotenuse is I think that's an angle bisector. Miss, if I hopefully I didn't botch that, Miss Wynn will have me. So we've got 60 miles. So that's an adjacent side and the opposite. So we've got opposite over adjacent.
Tan.
Yes. So this is one where we're going to do this. Tan inverse 15.2 over 60. Whenever you're looking for an angle measure, you know you're going to use the inverse.
Oh, yeah, that makes sense. $14.2.
14.2 is correct.
Thanks so much for helping me with this.
Oh, no problem. If you had by chance done it the other way and found this one, you would have had to subtract your answer from 90. If you would have looked for this angle. Okay?
Okay.
But it's always a good idea with the angle when you're working with the angle of depression ones to go ahead and write out that imaginary second triangle. Does that make sense?
Mm-hmm.
Did the dotted lines help clarify that for you a little bit?
Yeah.
Okay, praise God. I'm so glad. I really didn't want to confuse you. Do you have any other questions though about the other stuff?
No, I'm good.
Okay. Well, a good tool to remember is just write SOHCAHTOA at the top of your page. Unfortunately, Garrett, I will tell you still to this day, before I start these problems, I do it every time. So it just helps me to keep it in my head. You know what I mean?
It was very helpful.
All right. Well, you have a blessed day.
You too. Bye, Miss Sparks.
Bye-bye.